Okay, eighth graders. Today we're going to learn about the different types of plate boundaries. There's three major types, so let's go ahead and get started. The first one that we're going to talk about is convergent boundaries. Now, when something converges, as you guys probably know, it means it's coming together. So, convergent boundary is no surprise. It's where two plates collide into each other. So they're going toward each other. So like two cars crashing into each other. The thing about convergent boundaries is, though, we have two different types of crusts out there. We have continental crust, which is what we live on as human beings, and then we also have oceanic. Now, the difference between the two, as we already discussed, is oceanic is denser but thinner, and continental crust is thicker but not as dense. So when they collide with each other, depending on which is colliding into which, we get different results. So let's take a look at these results. The first one we're going to talk about is an oceanic crust running into a continental boundary or continental crust. As you can see there, the dense oceanic plate collides with a less dense continental plate. Gravity obviously is pulling down on the heavier stuff, so it's pulling down on the oceanic crust. And so what's going to end up doing is it's going to end up sliding underneath the continental crust. This area where it's sliding underneath it is called a subduction zone. Now, even though it's happening really, really slowly, there's a lot of it. I mean, this is a big area. And so we get a lot of friction. And that friction generates, obviously, heat. And the heat then causes the rocks of the plate to melt and turn into magma. Now, you can guess that magma, being close to the surface of the Earth, is going to create some land features, like, you guessed it, volcanic mountain ranges. We'll talk about that in a second, though. So where these two meet, though, there is, well, it's called a trench. Basically, it's a ditch where the oceanic plate is sliding underneath the continental plate. It creates this deep ditch where the dense oceanic plate subducts under the less dense continental plate. And you can see this around Peru and Chilean Trench. If you know anything about Chile, it's very mountainous, and that's one reason why, is because just right outside that, there's an oceanic crust sliding underneath the continental crust. But also Chile has volcanoes, and of course, so does the western part of the United States, too, part of it. So, because, again, like I just showed you or talked about earlier, because the friction causes the the crust to melt and turns into magma, that magma is very close to the surface. And just with the heat and the pressure, the gas and things like that, it causes these volcanic mountain ranges. We have one in state of Washington and Oregon. That's where Mount St. Helens erupted, and we'll talk more about that later on this year. And the Andes Mountains, which is again in Chile. Here's a nice picture of kind of what's going on, because you can kind of see right here is we have the heavy oceanic plate. Okay, so this is obviously heavy. Or dense, maybe, you know what, I should probably use dense, that's probably a better term. So let's try that again. So here we have this dense oceanic plate. Yes, it's not easy to write with a mouse. Oh man. And then we have the lighter or not as dense continental crust kind of staying on top. You've got heat here. And of course, that causes volcanoes, which then cool and form mountains and things like that. Here's obviously the western part of the United States. Here's the state of Washington. Here's the state of Oregon, and you can see, like, we have Mount Hood, which is a volcano. We have Mount St. Helens. So it's not unlikely that you may experience a volcano in your lifetime in this area. Hopefully not, but you never know. Alright, and this slide, we see this is Mount St. Helens. This is in the state of Washington here, United States. And as you can see, this is a volcano that erupted back in 1980, and so you can kind of see here how it blew a good portion of the mountain apart. So it was a big major eruption, and again, this mountain is due to the subduction of a small plate that sits right to the west of the state of Washington and Oregon, in the Pacific Ocean there. There's a small plate in the Pacific Ocean, and it is subducting or sliding underneath the North American plate, and again, that friction and pressure is causing these volcanoes that are developed in Washington and Oregon. The Andes Mountains, again, in Chile, as we saw on Google Earth earlier this week, a big subduction zone right there, right off the coast of Chile, and this causes, obviously, again, volcanoes and these mountains, these volcanic mountains. When it comes to boundaries, we talked about oceanic to continental, but what happens when two oceanic boundaries come together? They're both dense, so the least dense one, the one that may be a little bit younger, is going to slide over top of the a little bit older one. So one does give, basically. The one that's a little bit denser, and usually that's the one that's older. Again, just like before, the gravity pulls the heavier plate down, and again, this causes a subduction zone, and again, just like the continental one, we get earthquakes and volcanoes. And these volcanoes can rise and become volcanic islands. Japan is an example of this, so are the Philippines and Indonesia. These land areas are created by two oceanic plates, one subducting underneath the other one and causing volcanoes that get large enough to poke out of the water. They also form these deep trenches. One of the deepest areas of the world is known as the Mariana Trench. It is a little outside of Japan, and that's what we, as of right now, we know that as the deepest place on Earth. And again, it's this two oceanic plates kind of coming together, and the older one kind of subducting beneath the younger one. But these are called trenches, and so they're deep. They're different than ridges. We'll talk about that a little bit later. But they have, the name is trenches. So here's again kind of a model, picture model of what happens when two oceanic plates collide. As you can see, one kind of stays, the other one goes underneath, and as you can see, just like with our continental to oceanic, we get volcanoes. Big differences again, because these are both oceanic. The volcanoes a lot of times will stay underwater until they get large enough to poke out, and then we have these volcanic islands. And again, Japan, Indonesia, Philippines, places like that are created by these things. The Aleutian Islands, I forgot about them. Those, again, part of the United States. They're not part of the continental United States, but they're off of Alaska. And again, lots of volcanoes here, earthquakes, and again, oceanic to oceanic plates right here, and actually a little bit down in here, and again causing those volcanoes and these islands to crop up. Marianas Trench is right here. There's Japan, so it's kind of between Japan and New Zealand, and Australia would be down in here. The last kind of convergent boundaries we're going to talk about would be continental to continental boundaries. Now, again, these plates are less dense, and so what ends up happening is neither one kind of give. They both basically get pushed up. So there's no subduction. Now, what ends up happening is because they get pushed up, no surprise, we get mountain ranges. And they're large mountains and ranges. So, I mean, these are some of the biggest ones we have in the world. But they're non-volcanic. So, you don't have to worry about Mount St. Helens. Or, sorry, you don't need to worry about Mount Everest ever erupting. It's not a volcano. That mountain, which is still growing today, it grows like an inch or two a year, is still growing because the India plate, or the plate that the continent of India is on, is still moving toward the Eurasia plate. And it's kind of like a car crash, and both cars are of equal size and equal density, and they just kind of get pushed up, and so that's kind of what's happening there. And of course, there's a nice kind of overview picture of the Himalayas. You can see very large mountains, but no volcanoes. Our next type of boundary is called a transform boundary. And what this is when two plates are sliding past each other, or occasionally we have two plates that are actually going in the same direction. Now, transform boundaries are unique in the fact that you still get earthquakes, just like the other boundaries, and all boundaries have that kind of in common. But you don't get volcanoes, and you're not going to get large mountains, and you're not going to get major waterways, no oceans or anything like that. No big trenches, no rifting. I'm not gonna lie, I'm not gonna tell you there's no physical like crack or anything, because a lot of times there are, but basically the two plates are just kind of sliding past each other, and then through erosion and things like that, things get filled in, so you're not going to get the big geographical landmarks that you would get with the other two types of boundaries. Here's a picture of the San Andreas Fault. You can kind of see where the crack is. So on one side this is one fault, this is the other fault, and as you can see the arrows here, one plate's going this way, one plate is going this way, and so they're rubbing up against each other. But what you don't see is volcanoes, mountains, and things like that. But earthquakes, obviously we get quite a few earthquakes. California experiences earthquakes quite often, so it is part of living by a transform boundary.